Welcome back to KKEnergyHub. Today we're diving into a concept that's central to logic, and while it can seem a bit abstract, I'll show you that it's quite approachable once we break it down. We're talking about first-order logic, which is widely used in mathematics, philosophy, and computer science. Let's explore how this formal system works and why it's so powerful. At its core, first-order logic is a way of describing relationships between objects. You can think of it like a super precise language, helping us say exactly who or what something is and how different things relate to one another. Imagine we're making statements like, all students love learning. We're talking about all individuals who fit into the category of students and giving them a shared property. They love learning. In first-order logic, we express this using something called a universal quantifier, which means for all. The statement, all students love learning, would look something like this. Here, the symbol means for all x, and x represents an individual student. The arrow means implies, so this reads as for all x. If x is a student, then x loves learning. It's a precise way to say something we could just say in natural language, but now we're putting it into a form that's perfect for logical analysis. First-order logic uses two main tools to describe the world: universal quantifiers and existential quantifiers. The universal quantifier for all applies to everyone or everything in a group, like saying, all students. The existential quantifier there exists is used when we want to say, there exists at least one. For example, if we say, there is a person who is a doctor, we could express this as, this means there exists at least one individual X, who is both a person and a doctor. The symbol here means and, so the statement is combining two facts about this X. They are a person and they are a doctor. Think of these quantifiers like fishing nets. The universal quantifier is a big net that catches everything, while the existential quantifier is a more specific net, looking for just one fish that meets the condition. Let's dive deeper with another example. Suppose we want to describe something more complicated, like all doctors treat patients, but not all doctors prescribe medicine. In first-order logic, this would look like this. Here, we're saying two things. First, all doctors treat patients, but we're also noting that at least one doctor doesn't prescribe medicine. The symbol means not. So this second part means there exists at least one doctor who does not prescribe medicine. Now, let's talk about predicates. In first-order logic, predicates describe properties of individuals or relationships between them. So when we say something like John is a student or Mary is a teacher, the words student and teacher are predicates. They describe the roles of John and Mary. A predicate like student X is like a label we stick onto X, saying that this individual X is a student. So if we have X and Y and we say, this tells us that X is a student and Y is a teacher. It's a simple but powerful way to categorize things and keep track of their relationships. First-order logic is often used behind the scenes in things like database queries and AI systems. Think of it as the logic behind systems like social media, where algorithms determine relationships, connections, and preferences. It's like the brain of a system that helps figure out who knows who, or which posts should be shown to which people based on certain rules. Of course, first-order logic has its limits. It's great for dealing with specific objects and their relationships, but it can't handle more abstract ideas like sets or functions. For example, if we wanted to talk about the set of all relationships, we'd need something more powerful, higher-order logic. But because of its simplicity, first-order logic is perfect for everyday reasoning and decision-making systems. So, why does first-order logic matter? It's because it helps us formalize reasoning. By taking something we already do, like making statements about the world, and giving it structure, we can analyze it more deeply. Whether we're working with AI systems, making decisions, or even solving puzzles, first-order logic provides the tools to make our thinking more precise. Today, we've explored the basics of first-order logic, from quantifiers to predicates, and seen how it can describe relationships in a clear, structured way. It may seem a bit abstract at first, but once you understand the framework, you'll see it's just a formal way of expressing everyday reasoning. Thanks for watching, and if you're interested in learning more about logic, reasoning, or even AI, don't forget to like and subscribe. See you next time.